Section 3-4, Day 2 on solving exponential logarithmic equations. We're going to review our one-to-one and inverse properties to solve equations, and we're also going to look at some models of real-life problems for exponential and logarithmic equations. So the first thing I want you to do is just try to do these three problems. Pause the video, do them, and then we'll go and see how you did on them. Alright, so I went ahead and solved all three of them. On the first one, I subtracted 2 and then divided by -1. So when I went to use the one-to-one property, I got log base 4 of 4 raised to the x plus 3, which was good, because then that canceled that to leave me with x plus 3. But on the right-hand side, I got log base 4 of -8, and that -8 must be greater than 0, so therefore, that question A there is no solution. On B, divided by 3 to isolate the logarithm. Rewrote it once again using one-to-one property, e raised to the natural log, so that would cancel and leave me with x minus 1 equals e to the 7/3. Added 1 to the other side and got 11.312 approximately. And then on C, we had the power property that needed to be used because there was a 2 in front and there was also a 1/3 in front. So we had to use the power property first, and then I used the product property to multiply the 3 times the x plus 6. Then I used the one-to-one property to say that x squared equals 3x plus 18. Went ahead and solved that quadratic, got x equals 6 and x equals -3. The domain must be greater than 0 on the first x right here, and then on the second x plus 6 must be greater than 0. So if x is greater than -6 and x is greater than 0, to satisfy both of them, it'd have to be x is greater than 0. So therefore x equals -3 is not part of the domain, so x equals 6 is your solution. Alright, on this next example, some problems you actually cannot solve algebraically the way that we have been doing, so we are going to solve these using the graphing calculator. Natural log of x is equal to x minus 3. So what we're going to do is we're going to set it equal to 0. So we'll do the natural log of x minus x plus 3 equals 0. Realize that that is by itself. And so I plugged it into the equation, so you can see that right here. And when I plugged that in, my graph looked like the first slide there. And so I want to calculate where the y value, because that right there represents the y, where y is equal to 0. So I'm looking for the 0, so I go to calculate on the calculator, and I hit 0, and it's going to ask me 3 questions. Left bound, so I pick a point to the left of 0, which I did right there. Hit enter. Right bound, picked a point to the right of the 0, hit enter, and then it's going to ask me to guess. And so I tried to pick one in the middle there, and I hit enter again. And you can see these arrows indicating that that's where you're hitting your left bound, right bound, and then your guess. And so then it gave me my 0 when y was equal to 0. So my solution is x is approximately 4.505. And so that's how we can solve using the graphing calculator and approximating a solution to an equation. Alright, now let's look at an example applying exponential functions dealing with compounded interest. So you've deposited $600 in an account that pays 7.25% interest compounded continuously. So now we know what type of formula, which formula we're going to use. How long will it take your money to triple? So knowing that, we're going to use the equation A is equal to PE raised to the RT because it's compounded continuously. We've deposited $600, so that's our principal. We know the rate is 7.25%, so it's a decimal 0.0725. How long will it take our money, so we don't know the time, to triple? So if we started off with 600, to triple would give us 1800. So we need to solve this equation for t. It's an exponential equation. Our variable is in the exponent, so we need to isolate the base, and then we'll use logarithms to solve. So we'll first divide by 600. That'll give us 3 is equal to e raised to the 0.0725. 0.25t. Since it's base e, we'll use natural log. And the natural log will cancel e, so we'll have natural log of 3 is equal to 0.0725 t, and then we'll divide both sides by 0.0725, and t will approximately equal 15.153. So it'll be about 15 years to triple our money. So once again, about 15 years to triple the money. On this last example here, we're looking at the average salary in thousands of dollars for public school teachers. It can be modeled by the equation. It is only talking about the years between 1980 to 2000, where t represents 1980. So that's important. So t is not 0 in 1980, it's 10. And so that's why when you see the equation, you also have a domain restriction between 10 and 30, which would be 1980 to 2000. During which year did the average salary for public school teachers reach $35,000? So what are we going to plug in here? Well, we know that y represents the average salary. It says that right up here. The average salary is y. So we know that this is 35,000, but it's in thousands of dollars. So we'll do 35 is equal to negative 39.2 plus 23.64 natural log of t. During what year did the average salary reach 35,000? So we need to solve for t. We'll add 39.2 to both sides. That'll give us 74.2. Then we can divide by 23.64. And then that'll give us a value of approximately 3.1387. But I'm going to leave that in the calculator when I go and calculate this. So that's approximately equal to the natural log of t. So we're going to use one-to-one function, and we'll do e raised to the natural log so that it gets it to cancel. And so therefore t is equal to e raised to approximately 3.1387. So if you plug that into your calculator, you will get approximately 23.075. So if t is equal to 10 is 1980, then t is equal to 23 would be 1993. You could think of it a couple different ways. If t was 0, that would be 1970, add 23 to 70, or add 13 to 1980. So in 1993, the average teacher salary is estimated to be about $35,000. And then there's my answer below. So that is it for the second day of 3-4. Once again, a lot more about the modeling part of it. And also we did solve using a graphing calculator. We had to estimate an equation. So on your summary, write down the important things from this lesson, and then once again we'll discuss that in class.